welcome to the deep dive.
Right.
We take a whole stack of sources and we try to pull out the most important nuggets of knowledge. And
That's right.
today we're diving into the ASME B30.5-2018 standard.
Yeah.
And this one is brought to you by Safety One Source. And this one's specifically for crane operators.
Yeah.
Aspiring operators, and those of you involved in safety and risk management.
Absolutely. And we're going beyond just like reading the rules, We're exploring the practical knowledge that can help you operate cranes safely and efficiently.
Right. And let me tell you, when I first got hold of this standard, I was really fascinated to learn about the sheer complexity of this thing.
I mean, it's unbelievable.
It's not just about pulling levers.
Yeah.
This is a whole world of calculations and safety systems and
absolutely
understanding how these massive machines really work.
Yeah. And, we're going to start with something that may seem obvious, but it's absolutely fundamental. Load ratings.
Okay.
Those charts in the ASME standard, the ones that tell you how much weight a crane can handle. Crucial.
Yeah. When I first saw those charts, my eyes kind of glazed over a little bit.
I hear ya.
They're dense.
They are dense.
But I get it. Exceeding those load limits could have disastrous consequences.
Yeah. It's not just about the crane tipping over, although that is a very real danger, but you're also risking structural damage to the crane itself.
Okay.
Potentially dropping the load, putting everyone on the job site at risk.
Okay. That's
good.
That's a vivid image I don't want to see in real life. So let's break it down. What actually determines those load ratings? What factors come into play?
It's a fascinating combination of things. The crane's stability is key. We need to make sure that it won't tip over under the weight of the load.
Right.
Then you have to consider the structural limits of the crane itself. How much stress can those components handle? And you might be surprised to learn that even something like tire pressure can affect the load rating.
Tire pressure? Really? I would thought that was more about keeping the tires from going flat.
It is, but think about this. Imagine a car with underinflated tires. It's wobbly and unstable, right?
Yeah.
The same principle applies to cranes. Proper tire pressure ensures a stable base, which is absolutely essential for safe lifting.
Yeah.
Everything's connected.
Okay, that's a good analogy.
Yeah.
So the ASME standard lays all this out in detail. What are some of the key things we need to pay attention to?
One of the most important is Table 5.1.1.1-1, and it shows how the type of crane and its setup dramatically affects how much of its tipping load it can handle.
Okay.
And it really highlights why understanding your specific crane type is so critical.
Can you give us an example of how this table plays out in real life?
Absolutely. Let's say you're operating a locomotive crane with its outriggers fully extended and properly set.
Yeah.
It can handle 80% of its tipping load, but take away those outriggers and that number drops to 85% for booms under 60 feet and even less for longer booms. That's a huge difference.
Wow.
And it could mean the difference between a safe lift and a catastrophic accident.
I never realized how much of an impact those outriggers have. So as an operator, knowing those specific numbers for your crane could be life-saving.
Absolutely it is.
Yeah.
That table's like a cheat sheet for understanding the basic stability limits of different crane types. It should be essential knowledge for anyone operating or working around these machines.
So we have the big picture from this table, but then we get into the actual load rating charts. And those can be pretty intimidating.
Right, yeah.
I know I've struggled to understand them in the past.
You're not alone. Those charts are packed with information.
Right.
But don't worry. We're here to help you decipher them.
Let's break down figure 5.1.1.3-1, which is a great example of a typical load rating chart.
Okay, let's do it. What are the most important things to look for? What stands out to you?
Well, first, you've got work area limitations. The chart will often show different zones, and those zones tell you where the crane can safely operate based on its load and configuration.
Okay.
Think of it like a map of the crane's safe operating space. So it's not just about how much weight the crane can lift, but also where it can lift it safely.
Exactly. Then you've got all the details about the boom, its length, its configuration, whether there's a job attached.
Right.
All of these factors impact how much weight the crane can handle.
And then there are those reeving diagrams,
Yeah.
which I have to admit I find pretty confusing.
I hear ya. Understanding the reeving, which is, how the ropes are threaded through the crane's pulleys,
Okay.
is critical for determining the load capacity, and you need to know the details of your ropes as well.
Okay.
The diameter, the strength, whether they're rotation resistant, it all matters.
It's like a giant puzzle where all these pieces have to fit together perfectly for the crane to operate safely.
That's a great way to put it. And there's one more thing that people often overlook. The notes and warnings on those charts.
Fine print.
Exactly. Those little tidbits of information might highlight specific limitations or special conditions or things to watch out for.
Right.
And ignoring them could have serious consequences.
Okay, I'm getting the message. Pay attention to those charts. No skimming allowed.
You got it. Every number, every note, every line on that chart is there for a reason.
Yeah.
It's all about keeping you and everyone else on the job site safe.
Now, we've talked a lot about stability, but there's a specific type of stability that I know trips up a lot of new operators. Backward stability.
Oh, yeah. Backward stability is all about making sure the crane doesn't tip over backward, which can happen if the center of gravity shifts too far back.
Right.
It's one of those things that seems obvious in hindsight.
Yeah.
But it can be a real challenge for new operators who are still getting a feel for the crane's balance.
It's like leaning back in a chair too far. You go past a certain point and you're going down.
Exactly. And, the ASME standard lays out specific criteria for different crane types to help prevent this. It all comes down to understanding weight distribution, making sure those outriggers are correctly set up, and even considering things like fuel tank levels.
With fuel tank levels, how does that play into stability?
Believe it or not, a full fuel tank on the front of the crane can actually help to counterbalance a load being lifted over the back.
Wow.
It's all about physics and that delicate balancing act.
I had no idea. It really highlights how much detail goes into operating these machines safely.
It does. And that's the beauty of diving deep into the standard, The more you understand these finer points, the better equipped you are to operate safely and confidently.
So we've been talking a lot about the crane itself, but what about the other components, like the ropes and the sheaves and the hooks? Are those covered in the standard as well?
Oh, yeah, absolutely. Those components might seem a little less exciting than the crane itself.
Right.
But they are every bit as important when it comes to safety.
Yeah, I mean, those are the things that are actually connecting to the load and lifting it up, so.
Exactly.
Yeah.
And the ASME standard has a whole lot to say about how to choose them, how to use them, how to inspect them.
Okay, so let's start with ropes, because I feel like there's a lot of variation in ropes. What are some of the key things to keep in mind there?
Well, one of the most important concepts is this idea of rope design factors.
Design factors? Okay. I'll be honest, when I hear that term, my mind goes a little blank. What does that actually mean in practical terms?
It's all about safety margins.
Yeah.
The design factor basically tells you how much stronger the rope is compared to the load that it's expected to carry. So it's like a built-in buffer to make sure that the rope won't fail even under stress.
So a higher design factor means a stronger, more reliable rope.
Exactly. And that's important because those ropes are subjected to a lot, tension bending, abrasion, fatigue over time.
Right. So they need to be tough.
They do. And the ASME standard, it sets these minimum design factors to ensure that the ropes can handle all those stresses.
That makes a lot of sense. Are there any other key points about ropes that stand out to you in the standard?
Yeah, it gets pretty specific about rope selection, for example. It explicitly states that fiber core ropes should never be used for boom hoists.
I'm curious about the reasoning there. Why are fiber core ropes a no-go for boom hoists?
Well, fiber core ropes, they're just not as strong or as resistant to crushing forces as steel core ropes and boom hoists. They need that extra durability to handle the forces involved in raising and lowering that big boom.
Makes sense. It's got to be a heavy-duty rope.
It does. It's all about choosing the right tool for the job, right?
Right, yeah. So we've got the right rope. We've got it selected. What about installing it and inspecting it? And what are some of the key things to keep in mind there?
Well, proper installation is really important, making sure that those end terminations are secure, and then regular inspection is absolutely critical, particularly for rotation-resistant ropes.
Rotation-resistant ropes, those sound fancy. Tell me more about those.
Yeah, those are pretty cool. They're specifically designed to resist twisting and untwisting underload, which can be a real problem for certain types of crane operations.
I can imagine, yeah.
But, because of their unique construction, they need a little extra attention during inspection to make sure that they're in good shape.
So we've talked about ropes. Let's move on to those sheaves. Now, correct me if I'm wrong, but those are the pulleys that the ropes run through, right?
You got it. The sheaves are all about reducing friction and wear on those ropes, and the ASME standard, it really emphasizes that the ratio between the sheave size and the rope diameter is really critical.
Okay, now why is that ratio so important?
Well, if the sheave is too small for the rope, it can cause excessive bending and wear, which weakens the rope and increases the risk of snapping.
Okay.
And on the flip side, if the sheave is too large, it can actually be inefficient and could even affect the crane's stability.
So it's kind of like Goldilocks and the Three Bears.
Yeah.
We need to find that just right size when it comes to sheaves and ropes.
That's a great way to put it. And, the ASME standard, it lays out those ideal ratios for different crane operations.
Okay, so we've covered ropes, we've covered sheaves now. Let's talk about the business end of the crane, the hook. What are some of the things our listeners should be aware of when it comes to hooks and crane safety?
Oh, the hook, that's where the rubber meets the road, right?
Yeah.
That's where the crane connects with the load. And it's also where things can go wrong in a hurry if we're not careful.
Right.
So the standard emphasizes several key points. First, those hook latches, they need to be in good working order.
Yeah.
We need to be absolutely sure that the load capacity rating of the hook is appropriate for the job we're doing.
Okay.
A hook that's not strong enough for the load is just an accident waiting to happen. And then finally, the standard talks about the need for hooks to be heavy enough to overhaul the line.
Overhaul the line, what does that mean?
It means that when the load is released, the hook needs to be heavy enough to pull the rope back up. If it's not, you can end up with slack in the line, which can cause tangles, snags, all sorts of problems.
So it's almost like a counterweight in a way.
It is. And, that's one of those details that people often overlook, but it can make a big difference in terms of safety.
It's those little things, right?
It is. And that's really the recurring theme here. Every detail matters when it comes to crane safety. It's not just about understanding the crane itself. It's about respecting every single component in the system and how they all work together.
And for anyone working in safety and risk management, this level of detail, I imagine, is super valuable when you're developing training programs or making sure that your team understands the importance of all these different elements.
Absolutely. Safety is a team effort, and having everyone on the same page, from the operators to the supervisors to the safety personnel, that's what makes a real difference.
So we've been talking about the mechanical aspects of crane safety, but what about the operator's experience? What about their environment? Does the ASME standard talk about that as well?
Oh, it does. You can have the safest crane in the world, but if the operator is uncomfortable or distracted or doesn't have a clear view of the operation, you're increasing the risk of accidents.
Right. It's all connected.
It is. So the standard addresses that as well. It talks about things like visibility requirements, cab design, safety features, all sorts of things to make sure that the operator has a safe and efficient working environment.
Okay, so let's dive into the operator's world a little bit. What are some of the key considerations for creating that safe and efficient cab environment?
So yeah, when it comes to the operator's cab, there are a few things that the ASME standard really focuses on.
Okay, like what?
Well, first and foremost, visibility is key.
Yeah, makes sense.
The operator needs to have a clear and unobstructed view of the entire work area.
Right, so they can see what they're doing, where the load is going, and make sure everyone's out of the way.
Exactly. And the standard actually specifies things like minimum window sizes and the use of safety glass, to protect the operator from flying debris.
Oh, wow. So it gets down to that level of detail.
Oh, yeah, it does. And it also talks about things like having a comfortable seat, adjustable controls and good lighting. Because if the operator's uncomfortable or strained, they're more likely to make mistakes.
Yeah, that makes sense. I mean, fatigue is a huge factor in any kind of job, really, but especially when you're operating heavy machinery.
Absolutely. And then there's the issue of noise. Crane cabs can get pretty loud.
Right.
So the standard encourages the use of noise reduction measures to protect the operator's hearing and reduce distractions.
It's really thinking about the operator's well-being, not just in terms of safety, but also their comfort and their ability to focus on the task at hand.
Yeah. A happy operator is a safe operator. That's kind of the philosophy.
Yeah, I like that a happy operator is a safe operator.
And on top of all that, the ASME standard also talks about the importance of operational aids, things like load indicators and anti-tube blocking devices.
Okay, now those sound like some pretty high-tech gadgets.
Yeah.
What do those actually do?
Well, a load indicator is basically a device that tells the operator exactly how much weight is being lifted.
Oh, that's helpful.
Yeah, it takes the guesswork out of it and helps prevent overloads. And then an anti-tube blocking device. It's a safety feature that prevents the load block from coming into contact with the boom tip or the boom point.
I could see how that would be a really bad thing.
Oh, yeah. That can cause serious damage to the crane and even lead to a collapse.
Wow. So these devices are really like extra layers of protection.
They are. They're all about preventing accidents before they happen and giving the operator that extra peace of mind.
So we've covered a lot of ground today, from understanding those complex load rating charts to choosing the right ropes and sheaves and hooks and creating a safe and comfortable environment for the operator. But as we wrap up, what's the one key takeaway that you really want our listeners to remember?
I think The most important thing is to never underestimate the importance of the ASME B30.5-2018 standard. It's not just a bunch of rules and regulations, it's a roadmap to safe and efficient crane operation.
Right, it's like a guidebook.
It is, and it's full of valuable information that can help prevent accidents, protect lives, and make sure that every lift is a safe lift.
Well said. I think this deep dive has been incredibly informative, and I hope our listeners feel the same way. Just a quick reminder that this episode was brought to you by Safety One Source, so a big thank you to them for their support and for their commitment to crane safety.
Absolutely, and thank you to all of our listeners out there for tuning in, and as always, stay safe.
Until next time.